Okay, guys, so the definition of derivative and the power rule. So really, it all goes together, okay? You'll need a sheet of paper for this, by the way. The definition of derivative is not this stuff. The definition of derivative is technically this limit and this limit. So technically, that's the definition of derivative, okay? We've been doing this a lot, and I know it does take a little bit of work, and you have to like factor. Sometimes you have to do long division or synthetic division or whatever. For this one over here, this we've been working on since Algebra 2. And then when the limit as x approaches 0, or sorry, the limit as h approaches 0 is in front of it, then that's actually the definition of derivative. This will work on a lot more in calculus, and we'll go back to this in calculus as well, okay? So today we're going to learn a shortcut. So first of all, how do you write derivative? Well, there's a lot of ways. So the one way to write it, we write like y prime, f prime. You can also write this. This means the derivative of y in terms of x. This is the derivative of the function in terms of x. And then if we take that multiplication and we bring this forward, this is the derivative in terms of x of f of x, of the function. So these all mean the same thing. So when you see this, you're supposed to know, oh, I take the derivative. I'm going to do the shortcut that Ms. Tan was talking about, okay? So the derivative is the result of mathematical differentiation. What is differentiation? When you differentiate, you're taking a derivative. So it's a change in quantity. So you know when you take a derivative, it's the limit of the slope. A slope is y minus y over x minus x. So that's a change in quantity. So differentiation, instantaneous rate of change, those are all taking the derivative, okay? And then what is the derivative? The derivative is the slope of the tangent line. So all of these give us the same thing. It's the slope of the tangent line. So when you have a point anywhere and you have a curve and you want to find the tangent line, so it's that whole roller coaster thing where the slope is positive, the slope is 0, the slope is negative. This is the slope of that tangent line, okay? So I hope that you were in class and then you did our little like rules without rules, because if you don't know what I'm talking about, then these make no sense, okay? The scalar multiple rule is just saying when you have some sort of scalar, when you have anything times x, the derivative is just that anything. So the derivative of 5x is just going to be 5. And we talked about y together. So this is technically 5x to the first power. 1 times 5 is 5. And then this becomes x to the 0 power, which is really just 1. So a quick way is just to realize, oh, 5x, the derivative is just 5. The derivative of 80x is just 80, okay? The constant rule, we've talked about too. So the derivative of any constant is 0. The reason for that is because, let's say this is 700, x to the power of, if we had to add an x, then you would say this is x to the power of 0. Well, if this is x to the power of 0, 0 times 700 is 0. So that's why the derivative of any constant is 0. And then right here we have the power rule. So the power rule, okay, so I'm going to skip ahead. We did something like this in class together. So this is the power rule. This is just a serious power rule, okay? So let me remind you of the power rule. So all you're doing is the 6, you bring forward and you multiply, and then you minus 1. Bring forward, multiply, minus 1. Bring forward, multiply, minus 1. This power is 0, so multiply, you get 0. That's why we don't write anything. So the power rule is really what we like see, what we do if it's just an x, okay? So final answer. But then if it's not just an x and it's a quantity, then we do the same thing. So notice like a and then to the power of n, we multiply, you get an, and then minus 1 right here. So we do the same thing, and then times the derivative of the box, times the derivative of the inside. So in this case, it would be times the derivative of x. Well, the derivative of x, what's the derivative of 1x? 1. So for these, we're doing it without realizing that we're doing this, okay? For this one, your example, y equals when you take the derivative, 4 times 6 is 24. You leave this, do not change it, and then to the power of 3. And then times the derivative of the inside. So there's your 6x squared. So the derivative inside plus 0, that's why it's 6x squared. Multiply a little bit, and then you get this. Okay. Notice your beginning and your end, see that box and that box? It does not change. Don't take the derivative of the inside in the first step. So in the first step, it stays the same, and then times the derivative of the inside. Okay? Okay, so you guys already wrote this probably. So B. Something like this, we don't know how to do yet. We can't multiply. So instead, it makes it easier if you just multiply everything out and then take the derivative. Okay? Write it nicely. Don't write equals. You have to write like y prime equals or f prime equals. So when you take a derivative, you can't just say equals. That's not okay. Okay. And then the last couple, I'll explain them, and you're free to not listen if you don't need the explanation. So the 4 comes forward, and then blah, blah, blah to the third power times the derivative of the inside, which is just 3. And then you multiply, final answer. Right here, here's your power rule. So 3 times 2 minus 1, and then the derivative of the inside is 6x. And then you just multiply a little bit, final answer. The last two, this we don't know how to do, but we can change it to negative 5 power. So if we change these, then now we can multiply, subtract 1, multiply. Oh no, there's a lawnmower, I'm sorry. Multiply, subtract 1, and then change it back into fractions. Okay, okay, here's the last one, trickiest one. So the derivative of 3x is 3, no problem. This is technically quantity to the 1/4 power. The 1/4 comes forward, and then you have blah, 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 and then 1/4 minus 1 is negative 3/4. And then times the derivative of the inside, but the derivative of the inside is just 1. So times 1, we don't have to write it. This, if we rewrite it, becomes this, right? Because this is a negative power, so it goes on the bottom. And then if we were going to rationalize, then we get this. So there's 3 of them here. We want 1 more to make it 4, and then we can bring it out. So if I multiply by 1 more of these 4th roots, that's where this comes from. And then when we bring it out, you have 4 times the quantity, 2 plus x, which is 8 plus 4x. So this is technically a quantity. Sorry, I didn't write it. I can write it in now. There, technically a quantity. Okay, so you're going to ask me questions on Google Classroom or on Monday is fine, but your homework is posted. For your homework, you're free to write it out loud or you can print it. I would print it and then write on paper. All right, I will see you. Good luck.